Alright guys, so today we are working with half angle formulas. So here are the three formulas that you'll have to know, one for sine, cosine, and tangent. So pause the video, take a second, copy that down, and then we'll move on. So in this case, the half angle formula, these are just more ways of finding exact values, given all the angle measures and exact values we already have from the unit circle. So if we want to find the cosine of 15 degrees, one thing we know is that 15 degrees is definitely not on the unit circle at all. So instead, what we want to do is we're going to write this as a half angle. So what we would say is that we would take the cosine of 15 and we're going to multiply it, the 15, by 2 over 2. Because that's 2 over 2 is just like multiplying by 1, so it still means the same thing. If we look at the half angle formulas, they're all over 2, so we want to make them match that equation. So when we do that, we now have the cosine of 30 over 15, or over 2, sorry. And in this case, we know we did it right if that 30 is an exact value, meaning it's on the unit circle. If it's on the unit circle, then we're in good shape. So we plug that into our equations. We're going to have that equals plus or minus 1 minus cosine of 30 all over 2. Alright, so then using the unit circle, cosine of 30 here is root 3 over 2, so we can get rid of that guy. So that's root 3 over 2, so plus or minus the square root 1 minus root 3 over 2 all over 2. So keep simplifying. Like I said, the hard part of this chapter is more or less the simplifying. So we're going to have 2 minus root 3 over 2 all over 2. And that's from getting a common denominator. So instead of dividing by 2, you can multiply by a half. So you have plus or minus the square root of 2 minus root 3 all over 4, which would equal root 2 minus root 3 all over 2. Now the plus or the minus, where the plus or minus comes from, and that is you're trying to use the all students take calculus to determine whether or not this answer should be positive or negative. And to do that, we go back to this original part here. So cosine 15 degrees, should that be positive or negative? And the answer is it should be positive because it's in quadrant 1. And cosine, along with every other function, is positive in 1. So that would be a positive answer. And that's it. So that's how you're using the half angle formula. Let's look at sine of 11 pi over 12. Okay? So 11 pi over 12, if you want to convert that, you would in 165 degrees. Sometimes these are a little easier to work in degree mode. So here we're going to take the sine of 165, and we're going to put it as, multiply it by 2 over 2, so it fits a half angle. So then that gives us 330. So that equals the sine 330 over 2. 330 is on the unit circle, so we're going to have plus or minus square root of 1. Oops, that should have been a plus. I messed that equation up. 1 minus the cosine of A. So the cosine of 330 should be negative root 3 over 2. Or sorry, positive root 3 over 2. All over 2. So you have 2 minus root 3 all over 2 all over 2. And now you're starting to see a pattern probably here. lot of these are going to work out very similarly. So we have square root 2 minus root 3 all over 4. Because once again, we can't divide by 2, so we multiply by half. Okay, so that will equal plus or minus square root of 2 minus root 3 all over 2. And now lastly, the plus or minus, should that be positive or negative at 165? The answer is that it should be positive. So that would be positive square root of 2 minus root 3 over 2. That's your solution. Alright, so now same concept again, except you're given a triangle to work with here. So the triangle we're given to work with, we're going to draw off first. So it's in between 180 and 270, so it means it's in quadrant 3. Theta goes there, okay? So that's negative 3, that's a 5, that should be a negative 4. So then the sine of theta over 2, so you have plus or minus, or 1 minus the cosine of theta. Cosine of theta is negative 3/5. We're just going to put that in, all over 2. So then we continue solving here. 1 plus 3 over 5. Jeez, I'm really struggling here. There we go. 3 over 5, all over 2. Plus or minus. Alright, so try simplifying from here. Pause the video and then let's see what you guys come up with versus what I come up with. Alright, so you should end up with a positive 2 root 5 over 5. Now, how do I know it's positive? That's kind of a tricky part. What you have to do in this instance is it's all based on where sine of theta over 2, what quadrant that's in. So we don't know it. We know theta is in 180 to 270. So what you end up doing is you end up dividing theta by 2 so it matches this angle measure. But since this is an inequality, just like in algebra 2, you have to divide everything by 2. So we know that 90 is less than or equal to theta over 2, which is less than or equal to 135. So theta over 2 is in between 90 and 135, which is quadrant 2. And then is sine positive or negative in 2? And the answer is that it's positive, so you get the positive here. Alright, try the cosine one. Pause the video, and let's see if we get the same answers. Alright, follow the work along there with cosine of pi over 2. I did skip a couple steps, like from here to here. I multiplied by 1/2 to get that, and then simplified. A lot of this stuff, as you all know by now, is all simplifying fractions and radicals, so hopefully that stuff's starting to come back to you because it's pretty important. Alright, lastly, identity here, proof. This right here should look like a formula we've done this chapter. And I'll give you a hint. It has a sine of it's a sine of double angle thingy, so it should be sine of 2 theta. So that whole identity equals the sine of 2 times whatever the angle measure is, which is x over 2. 2's cancel, leaves you with a sine of x. You could have also done it where you replace this with the sine of, the half angle for sine, half angle with cosine, distributed, multiplied, all that nonsense, and got the right answer, but it's a lot more tedious. And it's a lot easier if you do a substitution first. Alright, so that concludes today's lessons. If you want to take a look here, so kind of look at those are the problems for the homework. So pause them, go back to the video, make sure you get them down. Alright, so hope this makes sense. We'll be talking about it more tomorrow.